Welcome. Synapses. Synapses. Introductions, atom, charges, transfer of charges, flow of charges, electric circuit, and its types, effect of current, applications of electricity, conclusions, reference. Say electricity. Introductions. All things we use in our life are made up of elements. Each element is made up of atoms, which is the smallest unit. John Dalton, the scientist, considered that atoms cannot be divided further. But it was found our latest Rutherford goal-full experiment that atoms are made up of particles like protons, electrons and neutrons. Moment of electrons in a material constitutes electric currents and generate an energy is called electric energy or electricity. Washing machine, electric iron box are some of the applicants which work with the help of electricity. In this topic, we'll study about electric charge and how they are transferred. Atom. So an atom consists of protons, electrons and neutrons, which are called subatomic particles. Protons and neutrons are found inside the nucleus, which is at the center of atoms. Electrons revolve around the nucleus, different paths called orbits. In an atom, the number of electrons will be equal. There is a force of attraction between the protons in the nucleus and electrons in the orbit. Electrons in the inner orbit are strongly attracted by the protons. They cannot be removed from atom easily, but the electron in the outermost orbits are loosely bound and they can be easily removed from the atom. Charges. So, charge or electric charge is the basic property of matter that cause carried by the subatomic particles like protons and electrons. A charges can be neither be created nor be destroyed. There are two types of charge: positive charge and negative charge. The protons carry positive charge and electrons carry negative charge. There is a force of attractions and repulsions between the unlike charges attract each other and like charges repel each other. Electric charge is measured in Coulomb C. Small amount of charge that can exit freely is called elementary charge E. Its value is 6.02 in 10 power minus 19 C. This is the amount of charge possessed by each protons and electrons. But protons have positive elementary charge plus E and electrons have negative elementary charge minus E. Since protons and electrons are equal in number, an atom is electrically neutral. Transfer of charge. As we saw, the earlier electrons in the outermost orbit of an atom can be easily removed. They can be transferred from one substance to another. The substance which gains electrons become negatively charged and the substance which lost the electrons become positively charged. Transfer of charge takes place in the following ways. Transfer of charge are in the following way: transferred by frictions, transferred by conductions, transferred by inductions. So, transfer by frictions. Comb rubbed with hair grains electrons from the hair and becomes negatively charged. These electrons are accumulated on the surface of the comb. When a piece of paper is laid into bits, positive and negative charge that present at the edge of the bits, negative charge in the comb attract a positive charge in the bits. So, the paper bits are moving towards the comb. While combing, a hair charges are transferred from the hair to comb due to frictions. If the hair to comb due to a frictions between the hair and the comb, reduce the number of electrons transferred from hair to comb. Hence, rubbing a certain metals with one another can cause the built-up electrical charge on the surface. From this, it is clear that charge are transferred by frictions. Similar effect can be seen when we run a few materials with one another when a glass rod is rubbed with a silk cloth. The free electrons in the glass rod are transferred to silk cloth. It is because the free electrons in the glass rods are less tightly bonded compared to that in the silk cloth. Since the glass rod loses the electron, it has a deficiency of electrons and acquires a positive charge. But the silk cloth has excess of electrons, so it is become negative charged. From this we know that when two materials are rubbed together, some electrons may be transferred from one material to the other, leaving them both with a neat electric charge. Next, transfer by conductions. When the ebonite rod is rubbed with woolen cloth, electrons from the woolen cloth are transferred to the ebonite rod. Now ebonite rod will be negatively charged. When it is brought near the paper cylinder, negative charge in the rod are attracted by the positive charge in the cylinder. When the cylinder is touched by the rod, some negative charge are transferred to the paper. Hence, the negative charge in the rod are repelled by the negative charge in the cylinder. Thus, we can say that the charge can be transferred to an object by bringing in it contact with a charged body. This method of transferring charges from one body to other body is called transfer by conductions. Next, transfer by inductions. We saw that we can charge an uncharged object when we touch it by a charged object, but it is also possible to obtain charges in a body without any contact with water. Charged body. The process of charging an uncharged body by bringing a charged body near to it, but without touching it is called inductions. The uncharged body acquires an opposite charge at the near end and similar charge at the further end. Similarly, when a positively charged rod is brought near an uncharged rod, negatively charged electrons are attracted towards it. As a result, there is an excess of electron at nearer end. The nearer end of uncharged rod becomes negatively charged and far end is positively charged. Flow of charge. Suppose you have two metallic spheres are having a more negative charge and other having more positive charge. When you connect them both with the help of metallic wire, excess electron from the negatively charged sphere will start flowing towards positively charged sphere. This flow continues till the number of electrons in both the sphere is equal. Here the positively charged electron is said to be a higher potential and negatively charged sphere is said to be at a lower potential to higher potentials. This is known as the electric current. The difference between these potential is known as a potential difference, commonly known as voltage. Before the discovery of the electron, it was considered that electric current is due to the flow of positive charge. Flow of positive charge is called convectional current. Convectional current flow from higher potentials to lower potentials. Electric circuits. We saw that when two positively charged spheres are connected by a metal wire, electrons flow from this sphere which is at a lower potentials at this sphere at higher potential. Similarly, two terminals of a battery which are at a different potentials are connected by the metallic wire. Electrons will flow from negative terminals to positive terminals. A path through which electrons flow from one terminal to another terminal of the source is called electric circuit. A simple circuit consists of four electrons, a source of electricity, path of conductor through which electricity flows, a switch to control the circuit, and electrical resistor, which is any device that requires electricity to operate. So the above figures show a simple circuit containing a battery, two wires, key and electric bulb. The source can be a battery or the electric outlet in our room. So the electrical resistance refers to a device that consumes the energy. The control key is a mechanism that is used to short, stop, regulates the electric current. When the key is on, the electron from the battery flow through the circuit from the negative terminals, through the wire conductors, then through the bulb and finally back to the positive terminal. The light glows when current is flowing through it is filament. There are two basic ways in which we connect these components, serial circuit and parallel circuit. So series circuit. A series circuit is one that has more than one resistance but only one path through which the electrons can travel. From one end of the battery, the electron can travel from one end of the battery. So the electron move along a one path with no branches through the resistance to neither. And of the cells, all the components in a series circuits are connected end to end. So current through the circuit remains same throughout the circuit, but the voltage gets divided across the bulb into circuit. We saw that series circuit, same current travels through every resistance and the voltage will be different across each resistance. Let us consider three bulbs connected in series. Let be the current through the circuit V1, V2, V3 be the voltage across each bulb. So the supply voltage V is the total of the individual voltage drops across the resistance. V equals to V1 plus V2 plus V3. Parallel circuit. In a parallel circuit, there is more than one resistance and they are arranged in many paths. This means charge can travel from one end of the cell through many branches to the other end of the cell. Here the voltage across the resistance remains the same, but the current flowing through the circuit can be divided across the resistors. Effect of current. When current is flowing through a conductor, it produces certain effects. These are known as effect of electric currents. These effects are known as electric current. These effects result in the conversions of the electrical energy into different forms of energies as heat energy, mechanical energy, magnetic energy, chemical energy, and so on. Applications of electricity: entertainment, healthcare, households, commercial, transport and communications. The electricity have been many were used. So conclusions. Imagining the world without use of electricity is very difficult these days. Small things like steady lamp to big things like a plane require electricity to operate. A human civilization has become very modern and electricity is needed everywhere. I hope all of you understand and prepare very well. Reference. Thank you.